Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Good morning to everyone. You are warm welcome to our online class. Dears, let us continue our fourth chapter, LCM and HCF. We have covered the first part of this chapter, LCM. What is the LCM? Least common multiple. We have studied two methods to find out the LCM, division method and factorization method, prime factorization method. Today we are going to discuss about highest common factor, HCF, the second part of this chapter, HCF. Okay, highest common factor. We have studied this term in deep in previous class, 5th class. Yes, highest common factors. What is factor? We have studied last class. What is factor? Factor is a number which divide exactly the given number. Okay, factor of a number, here 6, a number. The factor of 6, 2 is factor of 6. 2 is factor of 6 because this number 2 can divide the 6 exactly. It is why 2 is a factor. Then 3 also a factor of 6. Then 4, no, 4 is not the factor of 6 because 4 cannot divide 6 exactly. Okay, then 2, 6 and 1 can. Okay, these are the factors of 6. Then here our discussion about highest common factor. Highest common factor. Okay, yes, there are two methods to find out the highest common factor. First method, HCF by prime factorization. Prime factorization. Second method, HCF by division method. Okay, I just describe what is HCF, highest common factor. Let us take two example, 20 and 8. Sorry, 10 and 8. Okay, 10 and 8. It is the HCF of 10 and 8. First we have to find out the factors of 10. Factors of 10, 1 into 10. Here 1 into 10, 10. 2 into 5, 10. Then is there others? No. Okay. Then the factors 1, 2, 5, 10. 1, 2, 5, 10. These are the factors of 10. Then 8, 1 into 8, 2 into 4, then other? No. Then 1, 2, 4, 8. Then our question, what is HCF? What is HCF? HCF, highest common factor. We got the factors of each number and we have to select the common factor here. One is common factor, we can avoid because one is everywhere common factor. Okay. Then next 2. 2 is common factor here. 2. Okay. This CF. Okay. CF, 2 is common factor. Then 5, no. 10, no. Then 2 only. Then 2 is the highest common factor. Is there another common factor here? Then we check the highest common factor, largest common factor. Is there 4? Just imagine. Is there 4? Then we will select this 4 as HCF because 4 is the highest common factor here. Okay, there are two common factors, 2 and 4. Then we select 4. Please imagine that. Okay, yes, here 2 is the common factor. Okay, then I think you have cleared what is HCF. Okay, how can find out the HCF, highest common factor? There are two methods. First method, yes, prime factorization. Like LCM, we are going to study the method of finding HCF by factorization method. Okay, first question, find the HCF of 144 and 180 and 192 by the method of prime factorization. First find the factors of the given numbers. Okay, by factorization, prime factorization, let us find out prime factorization. Which are the questions? Numbers 144, then 180 and 192. Then first we have to factorize. Yes, 144 2. How many 2's are there? 72. Okay, 72. Then 36. Then 80. Then 9. Then 3. Okay. Okay, prime factorization. Did you understand? First we have to divide with the, we have to divide 144 by 2. Okay, 2 is the divisor, 144 is dividend. Okay, then 72 by 2, 36 by 2, 18 by 2, 90 by, 9 cannot be divided by 2. Then we select 3. Okay, then 3 get. Okay, yes. Next we have to find out the prime factors of 180. 180. Okay, which are them? Then 8, 4, 45. Then we cannot divide by 2 here. Okay, sure. Then 5, we can select 5 or 3. We can select 3. Okay, then how many 3's are there? Yes, 30. 10 into 3, 30. Then 5 into 3, 15. Then 30 plus 15, 45. Then 15. Then 5. 5, 1. Okay? Yes. Then next, 192. Sure. 192, 2, okay, then 2, 48 divided by 2, 24, 2, 12, 2, 6, 2, 3, 3. Please listen here. These first we have to factorize prime factorization of each number. Prime factorization of each number. Okay. After that, please take your textbook, page number 50. The following table can be constructed. Following table. There is a table. I can write at the top. Okay, I can write here or yes, table means number 144. 144. Then which are the numbers? 144 and 180 and 192. Then the factors 2 here 144 2 2 2 2 3 3. How many twos? 4 twos and double 3. Okay. Then 2 into 2 into 2 into 2 into 3 into 3. Here 1 2. Okay. 2 into 2 into 3 into 3 into 5. Okay. Then here 2 into 2 into 2 into 2 into 2 1 2 3 4 5 6 6 2. Okay, then 3. Okay, after that next step is very important. First we have to find out the factors, prime factors of each number by factorization method. Then second we have to write the chart or a table like this, like factorizing. Okay, after that please I just read it. Now 2 is a common factor in each of the numbers which is repeated at least twice. Okay, then we have to take each factor. First we can take 2. 2 is here. Okay, and here. Just let us 2, yes, here also for 144 also and 180 also 192. Okay, 2. Then let us take 1 2 here. Let us take 1. Let us take out 1 2. Then next 2, yes, here, here, here. Then we can select that 2 also. Please listen here carefully. Then 2 here, but there is no 2 in 180. So we cannot select. We cannot select. Okay. Then only double 2. Please listen here. Here 1 2, here also, here also. Then we selected 1 2 from each of this number. Okay, because all numbers contain 2 as a factor. It is why we take 1 2. Then next 2, yes, there are 2. There are double 2s for each the numbers factors. Then 2 here, but there is no 2 in the factors of 180. So we can avoid. Okay, ignore the 2. Next 2, there is no here 2 and here, but there is no 2 in the factors of 180. Okay, then 3. Here 3 and here also 3. Here also 3. Okay. Okay, these 3 numbers include as a factor 3. So we can select 3. Next, is there any number? Here 3, but and here are 3, but here no, another 3. Another 3. Okay, then 5. Yes, here 5. There is no 5, there is no 5. We cannot select. So the condition to take out any factor, each and every number should contain that factor. If it is so, then let us take that factor and take out and write like this. Okay. Then let us multiply 2 into 2, 4. 4 into 3, 12. That is 12. Okay, that is the HCF. That is the HCF of 144, 180 and 192. The HCF of 144, 180 and 192 is 12. Okay, 12 is the highest common factor here. Highest common factor here. Okay, I think you have understood. Okay, there are examples, so you have to take your notebook and a pen and you have to write down. Okay, first step we have to factorize, then we have to select the write down the factors. Okay, after that we have to check each and every factor, it includes in all numbers or not. If all numbers includes the same factor, then we have to select that factor, then next factor, and we have to check. After that we get 3 factors here, then we have to multiply at last, then we get a product. That product is the HCF. Okay, yes. There is example 2. You just write down. It is very simple question. Find the HCF of 36, 42 and 30 by prime factorization method. First find out the factors of 36 and 42 and 30. Okay. Yes. Then it is very simple. Please write down. If you have a doubt, you can ask. Then HCF by division method. Second method is division method. Okay. Division method. Division method. It is not like the division we have studied, but it is a new division method. Okay, long division. It is known as long division. Okay, I just read. Let us now try another way to find out HCF in this method. HCF, the last division of the numbers. The last division of the numbers means direct, you can say HCF is equal to last division of the numbers. It means the last divisor of the division is HCF. Okay, there are steps to find out the HCF by division method. Find the HCF. First question, find the HCF 24, 16 and 42 by using the division method. I just write down here. Okay, please listen here. It is very important and it is very simple to understand if you are here with your full attention. Okay, 24, 16, 42 division method. Then if you are asked to find out the HCF by division method, the HCF of 3 number or 2 more number, you can select whatever number. You can select 24 and 16 or 16 and 44, 42 or 42 and 24, whatever may be. Here our textbook selected first 24 and 16. 24 and 16. First 2 numbers. Okay. Then what we'll do here? We have to divide. We have studied the smallest number should be the divisor and the largest number should be the dividend. Okay. Otherwise we cannot divide. Okay. We can divide third number, these 3 numbers simultaneously. Okay, please listen here. We cannot divide 3 numbers at a time. Okay, yes, sure. Then we can select 2 number. Yes, 24 and 16. Then what is the divisor here? 16. Sure, because this is the smallest number. And dividend 24. Listen here. It is not like the division we have studied previously. It is a new type of division. It is known as long division method. Long division. Long division. It is going to long. Okay? Yes. Please listen here. How many 16s are there in 24? Yes. Let's take right. Then okay. Then what will you do? 32. 2 into 16, 32. Then only here there are only 24. Then only 116 is there. Then quotient is 1. Quotient is 1. You cannot write quotient like here. But you have to write down the quotient like in your book where you have to write here. Okay, 1. Okay. Then 16 is divisor, 24 is dividend, and 1 is the quotient. 1 into 16, 16. Like the division we have studied. After that we have to subtract. You have to subtract. Then what will do? What will get? What is the answer? 4 minus 16. 4 minus 6. No. Then we just borrow 14 by 6. 8. Then 1 by 1 minus 1, 0. Okay. Then this is the remainder. Please listen here carefully. This is the remainder. Then remainder becomes the divisor and the first divisor becomes the second dividend. Please listen here carefully. Please listen here carefully. This is the remainder here. Then this remainder becomes the next divisor and the first divisor 16 becomes the second dividend. That is the long division method. Long division method. Okay. Then it becomes what? Division. It becomes divisor. Then the dividend here 16. First divisor. Okay. Yes. Then here quotient. Okay. How many 8 are there in 16? 2. Sure. 2. Then 2 into 8, 16. Okay. Then we get 0. The long division ends here. If you get 0 at last as a quotient, then our division end. Okay, that is the last step of the division. Okay, long division method. Then here we get the HCF, highest common factor here, last divisor. Please listen here. Last divisor. Last divisor is the HCF of 24 and 16. Not all numbers, not the HCF of these all numbers, but the HCF of 24 and 16. Okay. So let us write here 8. The HCF of 24 and 16. 24 and 16 is equal to what is 8. Okay. 8. Then we have to find out what is the question. Question is to find out the HCF of 24, 16, 42. Then we just take only two numbers. There is another number 42. Then we have to find out the HCF of 42 also. What is this next step? Next step we take this 8 and 42. 8 and 42. Okay. We take 8 and 42. The HCF of these two number and next number. Please listen here. It is very simple but difficult if you are not careful here. Okay, then please listen here. Then we take the HCF of first two number 8 and the next number 42. Then we have to do the same steps. We have to do same steps we have done in this matter. Okay, so what is the step? We have to take the divisor and dividend here. Which is the divisor? Smallest number 8 is the divisor. Then which is the dividend? 42 is the dividend. Then quotient. How many 8 are there? 5. Sure? Yes. 5 into 8, 40. Okay. Then 2. 2 is the remainder. Then 2 becomes the next divisor and 8 becomes the dividend. Okay. Yes. Then 8. Then dividend. Yes. Here this is the sign of divisor. This is the sign of between divisor and dividend. Okay. Then 2 is divisor here, 8 is dividend. The quotient, yes, 4. 4 into 2, 8. Then 0. Okay. That is the last step. Then what is here? Dividend HCF 2, last divisor. HCF here, last divisor. Then this is the HCF of all these number. This is the HCF of all. Therefore, the HCF of 24, 16 and 42 is 2. This 2. Okay. Did you understand? I can repeat the steps of long division method. First, you have to take two number. You can take any number. Here first we take first two number and the smallest number should be the divisor and the largest number should be the dividend. After that we have to divide. We have got 1 as a quotient. Then we have to subtract. Then we get 8. Then 8 becomes the divisor and the first divisor becomes the dividend. Then we get quotient 2 and 2 into 8 is 16, 0. Then 8 is the last divisor is the HCF of these two numbers. Then we get the HCF of 24 and 16, 8. After that 8 becomes the, we have to find out the next HCF, the HCF of 42. It is to find out the HCF of 42. We select the HCF of first two number 8 and 42. Then we have to divide the long with the using the long division method. Then 42 becomes the dividend, 8 becomes the divisor. Then we get 5 into 8, 40. Then we get remainder 2. 2 becomes the next divisor and 8 becomes the dividend and the quotient 4. Then 8 minus 8, 0. Okay. The last divisor here 2. The last divisor here 2. Then 2 is the HCF of 24 and 16 and 42. Okay. The HCF here 2. HCF here 2. Okay. Understand? Yes. Please write down in your notebook. Okay. If you have any doubt, you just call me or message me. Yes. Then there are example 2 you have to do and practice 2 more questions. Okay. Exercise 4.2. Find the HCF of 1852, 1562 and 1870 by using division method. And there are, how many questions are there? 6 questions. Okay, you have to do and send our WhatsApp group. Then application of HCF. We have studied the application of LCM. Like this application of HCF. Find the greatest number which divides 1628, 1736 and 268, leaving the reminders 8, 11 and 13 respectively. Respectively means what? The remainder of 1628, 8. The remainder of 1736 is 11. The remainder of 268, 13. Okay. Then what we'll do? First we have to subtract 8 from 1628, 11 from 1736 and 13 from 268 and find the HCF. On subtracting we get. Okay, it is very simple. Okay, I can write down the question. 1628, 1736, 268. Okay. Third, 3 numbers are there. Like we have done at the first, we selected the 3 numbers to find out the HCF by division method. Here the application of HCF. So here question wants to remainder here 8, here 11, here 30. To remind 8 here we have to subtract. We have to subtract. Then what is the answer? What is the answer? 1620. 8 minus 8. Here. Okay. Here. $255. After that is the first step. We have to subtract. Then we get 1620. Here 1725. Here 255. Okay. Then what we'll do? Yes, we have to find out the HCF by division method. Okay. First we can select 1620. One has and 1725. We can take first 2 numbers. We should be the remainder and we should be the dividend. We should be the remainder which should be the divisor and dividend. Yes, that is the question. The smallest number should be the divisor. Here smallest number this, because this also here, but here 6, here 7. Okay, then it is the divisor and it is the dividend. Okay, it is the divisor and it is the dividend. Then what is the answer? Here there are only 1. How many 1620 in 1725? 1. Then we have to subtract. We get, yes, 105. After that, it becomes the divisor. It becomes the divisor and it becomes the dividend. Yes. How many? 15. Yes, sure. 15. Okay. 15. 105 are there in. Then what is the? Then we have to multiply. Then we get okay, please listen here. Where we reached? Yes. We subtract here, then we got 105. 105. Then it becomes the divisor. The first divisor becomes the dividend, and we get 15. After that, we have to multiply 15 and 105. This is the simple way to multiply. Yes. Yes. We can divide it as a 105 can write like this. Then we can multiply with the 50. Very simple. Then 115, 1500. Then 5 and 15, 5 and 10, 50, and 5 and 5, 25, then 75. Then this is the answer. Okay, 1575. 1575. Okay, very simple. Then we have to subtract 10 minus 5, 5. Here 1 and we borrow 1 here, then 11 by 7, 4. Then 5 minus 5, 0. Okay. Then 45. Answer 45. Then it becomes the dividend. It becomes the dividend. Okay. And it becomes the divisor and a dividend 105. Yes. How many 45s are there in 105? Can you say? Yes. Try your best. Two. Yes. Only 2. Then 290. Then 5 minus 0, 5. 10 minus 1. Okay. Yes. Then it becomes the divisor and a 45 becomes the dividend. Can you see? Yes. It is. I can write here. Okay. Then 45 becomes the dividend and a divisor 50. Yes. 150, 13, 45. Then how many? 3. 3 into 15, 45. 0. Then 15 is the 15 is the HCF of these two numbers. HCF of these two numbers, 1620 and 1725. Okay, then we have to find out the HCF of 255 and 15. Okay, that is the next step. Please write down in your notebook. In your textbook, it is a fault. The second step, it multiply 15 and 105. They write to 105 also there, but it is not correct. We just correct, edit it. Okay? Yes. Then we get 15. We get 15 as the HCF. Then there are another number which is 225. 225. If you, then you have to multiply 255. 25 or 55? 55. Then 50. Then you get the answer. How many times? 17. Okay. Seventeen times 20, 255, then 0. Okay. Yes. Then what is the answer? Here we get the 15. We get the 15. Please listen here. Here HCF is 15. Last divisor. Here last divisor is 15. So 15 is the HCF of all numbers. 15 is the HCF of all numbers means 1620 and 1725 and 255. These are the three number in your question. So the HCF of these three numbers is 15. Okay. Yes, simple method. Division, long division method. Then that is the application of HCF. Okay. Then there are example 2, example 3. You just read the question, and if you have any doubt, you can ask. Okay. Very simple. We have not enough time because we have to cover one more chapter. Okay. Exercise 4.3. There are how many questions are there? 8 questions. Okay, you just read, and if you have doubt, you can ask. Then relation between HCF and LCM we have studied in the 5th class. I just read. Let us now discover the relation that exists between HCF and LCM and two given numbers. What is the relation? Consider numbers 210, 210, then and 300. Please consider. And the HCF here. What is HCF here? You have to find out. Then 30 is the HCF here. Okay. HCF here 30. Okay. No doubt. You can find out. Then what is the LCM here? LCM. What is the LCM? Yes. Here if you select the LCM, then you can find out 200, 2100. 2100. LCM 200, 2100. Okay. Please listen here. You have to find out the LCM and HCF. I just write here. Okay. Because we have not enough time. Yes. Then HCF is 30 and LCM is 2100. Then our relation The product of LCM and HCF. Product of HCF and LCM. To get the product, we have to multiply. Then 330 into 2100 is equal to, what is the answer? Yes, 6000, 63,000. 63,000. Okay. Yes, the product of LCF and LCM is equal to 63,000. 63,000. Then the product of the number, given number, 210 into 300 is equal to same 63,000. 63,000. That is the relation. The product of LCM and HCF, product of LCM and HCF is equal to the product of two given numbers. That is the relation. LCM and into HCF into LCM is equal to product of two given numbers. That is the relation between HCF and LCM. Okay. Then there are examples, another examples you have to write down. Then exercise 4.4, how many questions are there? 9 questions. Okay. Then we have covered the chapter totally. Then tips to remember. I just read the main points to remember. Combined numbers have one as their only common factor. Thus, the HCF of any two prime or complex numbers equal to 1. The LCM of any two prime or combined numbers equals their product. The HCF of two or more numbers is never greater than any of the numbers. The LCM of two or more numbers is never less than any the numbers. The HCF of two or more numbers is factor of their LCM. The product of the HCF and LCM of two numbers equals their product. Okay, quiz time. You have to write down in your notebook. Okay, formatting assessment. There are 15 questions. Yes, then we have covered the 4th chapter. Okay, thank you very much for watching this video. If you have any doubt, you can ask. Let us see again. Assalamu alaikum wa rahmatullah.